Okay, moving on, we now have a projectile motion question, and as we've seen, these appear all the time. So we've got motion in 2 dimensions. We've got to think about our components, so we're thinking about trig to get our vectors. Now, how long does the projectile take to travel from point A to point B? So we are talking about time. So although they say they're saying, you know, how long, that's just the way we say time. Okay, so this is a pretty classic one where it follows the pattern that I've described before, that it's the vertical motion that is important here, because the amount of time it spends in the air is just about how it's moving vertically. The horizontal velocity is only going to affect how far it travels before it hits the ground, but it's not going to affect how long it is actually in the air. We're ignoring air resistance, so there's a couple of things we can think about here. Now, if I think about the time to take to go to this height h, then basically the time that it's in the air, which I'm going to call the time of flight, is just going to equal 2t for the time that it takes to go to that certain height. Now I just need to think about some stuff, some other information that I know here. I know that the final velocity in the vertical plane is going to be, actually I'll call that Vy, is going to be 0 meters per second, because that's what happens when you get to the top of your flight. I'm trying to find t. Now it's accelerating at, I'll say minus 10 meters per second squared, because it's in the direction against the initial velocity. Then what I've got to think about is what is my initial velocity in the y direction, and got to think a little bit about trig here. We're talking about sine theta times so v sine theta is going to give us the value that we want there. So we've got 24 meters per second times sine of 37 degrees, which is 14.4 meters per second upwards. Okay, so what do we know? We know V, U, A, and we're trying to find T. So my simplest equation for this is A equals V minus U over T. So, or T equals V minus U over A. So what have we got here? We've got 14.4 minus 0 over V minus U, sorry, I've done that wrong. It's 0 minus 14.4 over minus 10. I knew that didn't seem quite right. Minus signs cancel and we get 1.44 seconds. Now this is the time to go up, which means we need to think about the time to go down. So the time of flight is 2.88 seconds. Now the next thing, the maximum height of the trajectory h in figure 5. So we're only thinking about half the motion here. We don't need to think about what happens in the 2.88 seconds, but it's the 1.44. Now we're actually a little bit spoiled for information here, because we know several things about this, and you could approach it in lots of different ways. So if you think about it, at the start of this we knew V, U, A, and we want to find x as our vertical displacement. Now we know t as well, so you could really choose any of a number of equations to give you x. Now personally I would probably tend to stick with the information that's in the original question. So we know u equals 14.4, v equals 0, a equals minus 10, X, which is what we're trying to find in that vertical direction, is the question mark. That's what we're trying to find. So what we've got here is v squared equals u squared plus 2ax as our equation that will solve this one for us. So, well, 0 squared is just going to be 0. 14.4 squared plus 2 minus 10x. Okay, so what do we get? So 0 equals 209 minus 20x. So x equals that divided by 20, and we get 10.4 as our 10.4 meters as our answer. So you could do the other equation where you're using the time value that we've calculated previously. You'll get the same answer. Okay, moving on. Fred is riding his sled on snow, so we've got a mass. We've got downhill from A to B, starts from rest. From A to C, there's no friction force. What is the momentum of Fred and his sled at point C? Now, this is obviously going to be a multi-part question because there's a number of things that we can calculate here. Now, there are some other things to keep in mind, though, that we don't have all the information to approach the question in certain ways. Now, we've got a triangle here, and so you might think, oh, okay, look, it's a triangle, I can do some calculations here. We don't have enough information. We don't have an angle. We don't have enough side lengths, so you actually can't do anything in terms of trig and calculating, like a force vector down the hill. That's not going to work. So we need to think about something else we can find. We know a height. Now, if we know a height, we can calculate a potential energy. So this question is about energy transformation. Up here, he's got gravitational potential energy. And down here it will convert to kinetic energy. From kinetic energy we can calculate velocity, and from velocity we can calculate momentum. So, a little bit of stuff to do, but it's all pretty straightforward as long as you see where you're going. So first thing, we've got E gravitational equals mgh, which equals, now I just want to admit that yes, I'm cheating here, I'm not writing down all my variables, but I'm trying to make this quick so we can you can get through it fairly quickly. So mass is 60, gravity is just 10 times 12.8, and we get 7680 joules. So, and this equals the kinetic energy. Now, kinetic energy is, we know, half mv squared. Now, to get v out of this, you can rearrange it, or often it's easier to substitute and then rearrange stuff. Personally, my algebra is pretty good, which you'd kind of hope it was, given that I teach maths and stuff. You might like to have the rearranged forms of some of these on your cheat sheet, and look, to be honest, this equation you're going to use a lot, and that would be a sensible use of your cheat sheet. So rearranging this, I'm going to get v equals the square root of 2ek over m. So subbing into this, 2 times 7680 over 60, and we get equals, we get 16 meters per second. Nice round number, which suggests to me that we're on the right track. So what are we looking for here? We're asking for the momentum at C. Now, we know that the velocity doesn't change, so the velocity at B, when all that gravitational potential energy had turned into kinetic energy, is the same as the velocity at C. What that means is that the momentum, which is mv, is going to be, well, it's going to be mv. So we've got 60 kilos times 16 meters per second. We've got 960 kilogram meters per second. Now, you might have noticed when you were doing this that there's always, the units are pretty much always given to you in the Year 12 exam, so you don't need to worry about those, but it is good if you're conscious of what the right units are. Okay, at this point he runs off the snow onto grass where there's now a constant friction force, and he slows down to a stop after 6 seconds. What is the magnitude of the friction force as he travels from point C to point D? First thing I just want you to think about here, in the previous question we worked out momentum, and it's not uncommon that one question will lead into another one. However, that doesn't always happen, and this is a good example. Just because we've done momentum there doesn't mean that's the next thing we're doing. So if we read the question, there's nothing about momentum here. There's nothing about collisions there, but there is another idea that might be useful. There's a couple of ways we could do this. We know that he slows to stop at D after 6 seconds. Now, you could think about it in terms of straight line motion. We know his velocity, and we know how long it takes him to slow down. And so we could then calculate the acceleration, and we could then calculate the force. But there is an easier way of doing it. So, you know what, I'm actually going to contradict what I just said before. This question does follow on, but it doesn't follow on in exactly a momentum way, but what it does follow on is that it's an impulse question, because impulse, which is force times time, equals the change in momentum. Now we know his momentum, we know the time, and we want to find the force. So the easiest way of doing this would be is change in momentum over time, which would be 960, now it's kilogram meters per second, divided by 6 seconds, and so we get 160 newtons is the average force there. So I zigged and zagged on that one. You do need to think about what they're doing, but yeah, it's definitely not just following up with another momentum question, but it is a related concept. Okay, so that's the end of this section. I will put out the other one very soon. Remember, email me if you've got any questions.